Hello everyone. In this video, we will see how complex numbers appear while we're working only with real numbers. There is this very general rule that when you're working with real numbers, there is one big case that complex numbers appear. Complex numbers appear when we are trying to solve some equation. Well, the best example of this is when you're trying to solve x squared plus 1 equal to 0, then you say that, okay, this is x squared is -1. There's no real number, such number. So that's where you actually see the first not real number, and that is exactly what we called it as I. You see, to start with, we were working only with real numbers. The coefficients all were real numbers. But then suddenly, when you're trying to solve it, we get a complex numbers. So this is a general rule that you will notice. Let's see this in some examples and see how this happens. Okay. Find the roots of following polynomials. It means that set them equal to 0. This is quadratic, so I can use quadratic formula. Minus b plus minus root b squared minus 4ac divided by 2 times a. Well, if you do find the number under the square root, this is -15 over 2. And right away you see that there is no real root there, because square root of negative number doesn't make sense. However, since I know that root of -1 is a complex number called I can separate this thing and write it as root of -1 times 15, and that is where the complex number I comes in, and you see that I'm writing it like that. The other example, set this one equal to 0. So you see that x cubed plus 2x is equal to 0. From there, we can factor. So x squared plus 2 times x equal to 0. Times x is equal to 0. That means that either x is equal to 0 or x squared plus 2 is equal to 0. Well, in this case, I can take the number to the other side, find the square root. Definitely there is no real number such that happens, but that's where complex numbers appear. So this is plus minus root -1 times root 2, and that means that we are working with plus minus I times root. Okay. This equation could be found from different things. For example, find all the values of k for which the linear vector defined by this matrix is not invertible. Remember, not invertible linear vector field means that the determinant of the coefficient matrix is equal to 0. So determinant of the matrix here this is, well, I will do a quick calculation of that. This is 3 times determinant of k plus 2 -3 1 minus 0 times something plus 0 times something. So that will just give me quick calculation there. So 3 times k plus 2 minus -3 times 1. And that is 3 times k squared plus 2k plus 3. If we set that equal to 0, obviously this would mean that just k squared plus 2k plus 3 is equal to 0. This is quadratic. I can go ahead and try to use the quadratic formula. Minus b plus minus root b squared minus 4ac divided by 2a. But you see that under the square root, we are getting negative 8. While if it was back all day, you would say there is no solution. But now you have complex numbers. That means that you can write this as negative 8 there. And that would be negative 2 over 2 plus minus root negative 1 times root 8 divided by 2. And you see that this is negative 1 plus or minus. Root 8 is 2 root 2. And you simplify 2, you get I root 2. So there are two values, complex values for k, for which the matrix, the vector field defined by this guy is not invertible. Okay. And the last one, this equation can be a characteristic equation, characteristic polynomial. So determinant of a minus lambda I, which is determinant of 1 minus lambda 2 negative 1 3 minus lambda. This is 1 minus lambda times 3 minus lambda minus negative 1 times 2. That will give me lambda squared minus 4 lambda plus 3 plus 2, which is, well, yes, let me just write as 5. Now, this is a quadratic equation again. So anywhere you see quadratic equation, you can start using the quadratic formula. Minus b squared minus 4ac divided by 2a. And that is 4 divided by 2 plus minus root of what is there. So this is 16 minus 20. This is negative 4. But square root of negative 4 is, let me write it here, root negative 1 root 4, which is 2 root negative 1. And that's where you see that. Okay, simplify that one. This is 2 plus minus. Simplify that. It's just I. So it has two complex eigenvalue, 2 plus I and 2 minus I. So from this point on, whenever you're trying to solve an equation, you have to be careful that you may end up getting a number which is not real but a complex number.